Welcome everyone. Welcome to today's SORBA webinar on future-proofing your operations, integrating AI with legacy systems. It's now 11 o'clock Sydney time, so I better get cracking and start this webinar. Can I just get a little thumbs up from everyone that they can hear me okay and see the screen? We have thumbs up there, team. Excellent, thank you, team. That is perfect. And I see you've got your hands up there, mate. Have you got a question already? No, he's pulled his hand down. Very good. G'day, David. There's a few people registered, so I expect a few people to come in partway through. So I'd like to respect people's times. This recording of the webinar will appear on the SORBA University. So if you've missed this webinar or your friends have missed this webinar, please let me know and, let them know that the webinar will be on the SORBA University. All right. For those that haven't met me, my name is Peter Horsburgh. I'm the Asia Pacific Managing Director of SORBA and author of the 5 Habits of an Extraordinary Reliability Engineer. Everyone knows me as Seven. Okay, I'm a pilot and mechanical engineer, and you can see the airplane there on the screen. I'm also, as I mentioned, a mechanical engineer, and this is our latest project. I have 2 sons, and we have basically managed to get a Mazda RX-8 up and running. From something that was not going to something that is going, and it's now become our second car. And most reliability engineers ask me, you're a reliability engineer and you got one of those? I like a challenge, everyone. I do like a challenge. And I'm going to show you some of the challenges, talking about challenges today, that we have been faced with SORBA and legacy systems, and integrating that into the SORBA ecosystem so that we can use AI to perhaps optimize the process. But anyway, continuing on there, team, at the end, we're going to make sure that you guys have access to the SORBA University. You can have access to a SORBA Smart Data Engine virtual machine. We will be offering someone a complimentary proof of concept of SORBA. And of course, I'm going to give you a signed physical copy of my book. All right, excellent. All right, so hang to the end. You have to be here at the end to receive the prize. In your inboxes, you should see a workbook titled Future-Proofing Your Operations. It looks something like this on the screen. Please feel free to use this workbook to work through the content that we're going to cover here today. So yes, so it's a little thing, it's a little guide. As it states, it's a workbook to help you guide you through this particular, let's call it, maze of integrating AI into legacy systems. All right, next step there, team. Next step is to have a quick poll. There's a wonderful Ellie in the background helping me here today. And if she could open up the poll to everyone, and if you could answer those questions, it will help me tailor the content today for you good people. So if you could open up the poll there, Ellie, and when it comes to AI, you should see a published result there somewhere on your screens, but I'll talk you through it, what I see on my end. When it comes to AI, what concerns you the most? Disruption to existing operations and lack of in-house expertise to manage the AI. Oh, we're going to talk about that. Very good. Okay, I've got that noted. We will talk about that. So if I just hide those results, and I will publish this next result. So how would you describe your current approach to maintaining legacy systems in your operations? We're actively considering replacing them. we're maintaining them, but considering upgrades is the other. So I'm going to show you something a little different here today, that you may not need to replace them or upgrade them. So let's talk about that. Next one, what's the biggest challenge you face with your legacy systems? They've got limited scalability and flexibility. Yeah. Inability to integrate with modern technology. Oh, let's talk about that one. Certainly, we're going to talk about that today. All right. Next question. Publish the results. What would be the most important benefit from integrating AI with your legacy systems? Getting real-time data insights for better decision making. Awesome. Love it. We're going to talk a lot about that today because you good people are not the only ones. Excellent. And the last question here, if I just publish that result, how do you view the future of your legacy systems over the next 5 years? So I've got a little bit of a mixed bag here, team, on this one. They'll likely need replacing soon. We're planning to enhance them with new technologies like AI. Awesome. We're going to talk about that. And we've got one person here not sure yet, still exploring options. Excellent. Excellent. Rightio. That gives me a little bit of context there, team, around what you guys, good people, are interested in. So let's get into it. And I've got a little plan of attack here, how to integrate some of those results from the poll into what I'm going to talk about today. Excellent. Awesome. Thanks, team. All right, quick poll questions are done. Why future-proof your operations? You guys have sort of already indicated this. Legacy systems are still valuable, but they may limit growth, adaptability, and efficiency. Okay, we understand the necessity of enhancing and not replacing these legacy systems with AI solutions. I'm going to talk a little bit more about that. Okay. What we want to do, AI with SORBA enables predictive insights, improved efficiency, adaptability, future-proofing operations. And the big point here is you don't need a full system overhaul to do it. Okay, do not need a full system overhaul to do it. I'm going to show you some examples of how others have done it around the world. Awesome, team. Legacy systems are a foundation worth preserving. Some of these legacy systems are a backbone of industrial operations. I used to work for an organisation that was built, or some of their assets were built in the 1940s. Okay, we were dealing with legacy systems. They represent considerable investment, in that case, yes, across all different operating sectors. Okay, manufacturing, mining, utilities, etc., etc., etc. A lot of people have got old stuff there, team. Okay, the challenges with this old stuff, or these legacy systems, is that they have limited scalability. They can create a data silo. Some of you guys have indicated that already. They're not real efficient at handling large data. In fact, some cases can't, and have restricted flexibility. Right? What we want to do, and this is the way that we approach it, is we want to work with what you have. All right, we want to work with what you have, and maximizing your investment on those legacy systems, no matter how long ago, okay, so that you can avoid that costly replacement piece. All right, that's what this is all about. That's what this is all about, is trying to avoid that costly replacement piece. The legacy systems still work. Don't need to replace them. All we need to do is enhance them. All right. The AI advantage for legacy systems. Okay, we can use the data from these legacy systems to automate routine tasks, freeing up your people to do more stuff with their time. Okay, we can give you real-time data insights, and that's one of the things that you were most interested in from the poll. And of course, we can use the AI to increase operational efficiency. Right? We can optimize performance, minimize resources, reduce waste, increase outputs using the technical advantages that AI brings us in our plant. Now, if you're interested on the SORBA University, there you will see a webinar from yours truly on enhancing beer production. In fact, I believe one of our today's attendees actually attended that one. Yes, so if you want to jump onto the SORBA University and have a look at how we have helped people optimize their beer brewing process, please feel free to do so. All right. As I've mentioned, it's not about replacing the legacy systems, but it's modernizing and augmenting their current capabilities. All right. So the benefits you'll see is we can optimize processes. Just talked a lot about that. We can streamline workflows, automate tasks, reduce bottlenecks, and we can drive that whole thing by AI. Predictive maintenance, we can use the data produced by those legacy systems to start forecasting breakdowns, giving you PF from the reliability world, or in layman's term, warning time, okay, of an impending problem, right? With the ultimate aim there to cut unplanned downtime to keep your availabilities up. For those in manufacturing, your OEE is highly dependent on availability. It's your first variable. All right, data-driven decision-making, okay? Getting that data outside of those legacy systems and mashing it together with structured and unstructured data to allow you to make decisions that you need to have the confidence to move forward, okay? Problem solving, we need data to feed our problem solving. And if we haven't got that data, obviously we cannot hold our hand on our heart and say that this is the true cause. All right, team, are you ready to get technical? Can you give me the thumbs up, because I'm going to show you some examples now, and now that I've given you all the benefits and let's call it done the salesy stuff, let's get into some technical examples, and I'm going to start out small for you, team, and then I'm going to work up to something where we've done this, let's call it massive integration into all sorts of different systems on, I won't steal thunder, but it's going to start out small and work up. The first thing that I'm going to do is basically give you an introduction into the SORBA platform. Okay, so the SORBA platform can be made up of two parts. Okay, we've got part one here, which is related to the asset, and we can install a little, let's call it industrial computer called a smart data collector onto that asset. So it's one of the things that makes us different. Okay, we're not a cloud-based AI solutions provider. Okay, we are essentially an operating system to provide. This is one of the things that we do. Okay, all right. Now, what I'm talking about is how we start integrating data in. Typically, we will use what's known as a smart data collector to integrate these legacy systems. Okay, it's a small industrial computer, typically installed pretty close to the asset itself. All right. Then once this smart data collector is installed, we use some sort of communication mechanism. Okay, cellular, LTE, Wi-Fi to satellite, you name it, Ethernet. There's a whole heap of communications methods, and then we transmit and basically synchronize. So you can see here it's got a two-way street to what we call the platform. Okay, so the platform is installed centrally somewhere. All right, centrally somewhere. It can be local on your local network. Okay, it can be in the cloud, or we've also got a new term there, everyone. We call it the fog, where we're not sure where it is. Okay, so it could be local on the ground, it can be in the cloud, or it can be in the fog, or it could be any of those options. It doesn't really matter. All right. Can everyone give me the thumbs up that you understand that there's two parts to SORBA, two basic building blocks to SORBA, the smart data collectors and the platform? And if you walk away with that, I'll be extremely happy, okay? Because we lever off this fact to integrate legacy systems. All right. Thanks, team. We'll see the thumbs coming up there on the system. I'm running multiple screens here, team, so you'll see me looking up because you guys are up there, but my slides are down here. All right. Now, I've got these little guys here are known as SORBots. They're the machine learning, okay? The SORBots can reside on the platform or on the SDC. It doesn't really matter. We don't care. Okay. In some people think the SDC software is exactly the same as this software. Okay. It's exactly the same set of tools. It can be. It doesn't really matter. You can actually run the whole platform down here if you so choose. All right. So these little guys are SORBots. They're the AI. All right. The other thing that we do is interface into existing systems like Microsoft Teams and Power BI. Typically, we do that at the platform, but again, we can do it at the smart data collector level. Okay, it's really up to you, hence the term fog. All right, we're not really sure where it is, but it's actually producing it. Okay, there's lots of options here in where you actually install this. You know, and if you're a government-based organization, putting things on the cloud is not necessarily the optimal way to go. Okay, you don't have to. This whole lot can be installed on the edge, if you want to call it that, or on the ground. All right, first one there, team. First one that we're going to talk about is an install RAND compressor. All right, and this was used in a rail facility. Okay, compressors are very, very common in industrial plant. They happen to also be the most expensive energy source that's out there. Ingersoll is one of the largest manufacturers out there of compressors. These guys run a proprietary controller. Okay, so they build their own controllers. They don't use an off-the-shelf one. Okay, so what we did was we interfaced using an RS485 twisted pair, 2 wires, into the proprietary controller and talk to it via Modbus RTU. So we talk to it using the smart data collector and then simply synchronize to the platform to make that data available, okay, to everyone else. Right now, I'm going to talk about the data doesn't necessarily have to end up in SORBA. It can pass through SORBA and end up in other corporate systems. I'm going to talk about that later. The data doesn't necessarily have to stay in SORBA. It can be transmitted outside of SORBA into other systems, and I'll talk about that in a second. All right. Does everyone see how that one works? Here's our most simple example. Can you give me the thumbs up there, team? Okay. So we've interfaced into a proprietary controller using an RS485 twisted pair and Modbus RTU. All right. Excellent. Excellent. So there's a proprietary controller example. That's one way of doing it. Okay. I'm going to step it up now to a wastewater treatment plant. Okay. So these guys had an older wastewater treatment plant. It was controlled by PLCs. Okay. On the SDCs, we have drivers for all the major brands of PLC. Rockwell, which this was in the case, Allen Branley, Mitsubishi, etc., etc., etc. All the drivers to talk to a PLC are included inside SORBA. Okay. So what we simply did there was put a SORBA box, SORBA SDC, in the plant, told it where the PLCs were and what registers to read from, and then it just simply started synchronizing the data to the platform. Okay? So all of the drivers for PLCs are basically inside SORBA already, comes with it. There's no extra charge or anything like that for the drivers. And simply you do the configuration thing, tell it where the IP of the PLC is, what register you're looking at, and SORBA will just start reading it. All right. So we can hook into multiple PLCs at the same time. using one SORBA box. So everyone got that one? Everyone see how we interface into PLCs? Thumbs up there, team. Awesome. Awesome, awesome, awesome. All right. Now, this one is a personal one of mine. This is one that I've worked on personally here in Australia. Mining is king. So Liebherr 282 trucks. They are a little different to, say, your Caterpillar or your Komatsu trucks in that they do not follow American standards. They follow European standards. It's Liebherr. Okay. They use a protocol that is called CAN open. Okay. It is an open protocol, right, where it allows the it communicates. It describes the communication method. Like it's CAN open. It's pretty open, right? But you actually need a custom dictionary to actually read it, because what it does is give scope to the manufacturer, in this case, to actually custom have their own tags or data streams in that CAN bus. Okay, they were using a controller called a Contron on the truck. So anyway, cut a long story short, pardon me, team. This had one of the global mining equipment manufacturers fooled for about 5 years. All right, fooled for about 5 years. Okay, so they couldn't interface these trucks into their system, into their mining system, radio, because they didn't appreciate what they were dealing with, i.e. an open CAN protocol, okay, and they needed a custom dictionary, right? Because we're independent, okay, we've got no affiliations with OEM. Talked to us quite easily, and basically gave us all the information we required to write our own custom dictionary for these guys. Okay, and then of course we obviously installed these each of these assets with the smart data collector because they move. All right, and then we synchronized it in this case, and here's what the installation looks like. We synchronized the data in this case via Telstra. Okay, Telstra is an Australian cellular network company for those that are overseas. We just simply used it was a Technomics, I think, modem that just was hit hard and transmitted the truck via Telstra. All right, this is the smart data collector right here, and you can see here that we're collecting. We actually, on this version of it, we actually are collecting 2 CANs worth of information, i.e. the CAN running the truck. Okay, so everything running the truck, and the second one was designed for the engine. So the engine is a V20 in this case, an MTU engine, had its own CAN protocol. So we set the thing up so that we could suck that in at the same time. So we're getting all the information off the truck, payload, truck pressures, speeds, etc., etc. Plus, we're setting it up so that we could actually get the CAN information off the engine as well. So, because Liebherr didn't publish everything in their wisdom, you can see here that we were getting a separate GPS signal in, so we knew exactly where the truck was. So we're interfacing to a separate GPS. So we're interfacing to the truck, the engine, and a separate GPS, and then transmitting it. And then all they had to do was just plug in the power, and off they went. It was installed as a little kit ready to go with all their custom drivers and everything like that, and a wiring diagram so they could wire it into the truck. So this was a personal example that I worked on, helping the team here locally get this one installed. Does everyone see how that one works? You've now got a sort of picture of a real looking SDC. This is one SDC in the fleet. We basically select hardware based upon the customer's needs. Yeah, thanks for the thumbs up there, team. So if you give me the thumbs up that you can see how that one works, awesome. This one literally had a global mining house full for about 5 years, and we turned this around in about 3 weeks. Okay, so once we had the information from Liebherr, the process was we sniffed the can to make sure that we had it right and confirmed that the measurements that we were seeing on the can was actually correct to what Liebherr had told us, and we created the custom dictionary and a driver, and off we went. All right, we're going to get to the most technical one here. This is our fourth and final case study, and it involves a locomotive. Okay, in this case, an older locomotive. There is a whole heap of things going on on a locomotive, and they're not necessarily integrated, especially if we are talking about an older locomotive, which we are. Okay, typically the company that operates the locomotive have some sort of comms platform. Okay, so the requirement was to communicate the information that the SORBA SDC was collecting via their comms platform to the SORBA platform. So their SORBA platform was installed internally. All right, so we're using all of their comms because they had it all under control, because they sort of want to know where their locomotives are. There's a whole heap of systems here that we had to interface to. All right. In this case, they were not integrated on this particular locomotive. They were all separate, and our job was to integrate it all together. Okay. So all of these legacy systems of different types we had to integrate together. So a rough mud map of what that looked like something like this. Okay. So we were integrating to the MOXer, which is in the generator room. We're integrating to a battery monitoring system. We're integrating to what's known as a PTC system, a QES computer. The event recorder was separate on this machine, so it recorded all the events. Okay, we had the interface obviously to power over an Ethernet switch. We interfaced into 3 cameras. Okay, 3 cameras at the same time, and I'll give you a wiring diagram in a second. And we also interfaced because the customer required to know if the train driver used their mobile phone whilst driving the train. Okay, so they used a proprietary product called a transit hound. Okay, this transit hound is essentially a mobile phone detector. Okay, let's call it that. So if the operator picks it up, uses the mobile phone, it emits a signal or data to say, hey, this is going on. We piece that all together. So basically what we could do is basically confirm that the operator was using their mobile phone whilst driving the train, which is a big no-no in the rules in this country. Okay, because we could see everything else on the train. Okay, we could see how fast he's going, where he was, all that sort of stuff, based upon this little system diagram. Does everyone see that we've got all of these different inputs all coming into a single SORBA smart data collector? Can you give me the thumbs up on that? Awesome. All right, you ready for this, team? I'm going to the wiring diagram. This is what the wiring diagram looked like. All right. We partner with a number of different system integrators around the world to help us with this. You can see here we are integrating into the J1585 port. There's a little adapter there, and we adapt it to the SDC. There's the little Transit Hound mobile phone detector. We had it into this port here, etc., etc., etc. The fisheye cameras, we used a multiplexer to bring it in there. The Vitron battery monitoring was brought into there. You can see all the connections that we were using on the smart data collector to give you an idea of the capability of this particular hardware. Okay, this particular hardware was specifically selected for this application, and it is also railroad certified. i.e. it can handle the vibration, heat and dust potentially produced in a rail environment or a mobile environment. Okay, out of interest, we use the same ones on the mining trucks. Okay, because they were nice and robust and can handle the environment. Okay, we've got the battery monitoring in there. I've mentioned it. The team also made up custom cables. Okay, so this was produced like a kit, like the previous example, like the mining one. We supplied the SDC and all the cabling required to plug everything in, plus all the little black boxes required to do the interfacing. All right, can everyone see how we've interfaced all of these different data sources on the locomotives? Get an appreciation. I know there's a lot going on here on this slide, but you've got the idea of how complex we can actually go with interfacing data into SORBA from the various systems that were on the train, okay, or on the locomotive, better words. All right, thanks team. Awesome. Okay, so if you want to know if the SORBots will work on your machines, please book in with me now. Can introduce you to some really, really good system integrators that help us with the distributing of the software here in the Asia Pacific, and also the interfacing piece. Okay, some of them are actually on this call. I recognise that, and please get in contact with me. Happy to work through your particular issue and figure out a way forward and how we could actually interface your legacy systems into SORBA to make that data available to you. All right, and talking about data availability, right? Let's talk about how we would set SORBA up, or what we call best of breed, best in practice of actually setting SORBA up to get data from all different sorts of systems, and legacy being one of them, integrating it together and getting it to talk to corporate systems. All right. Hopefully, team, you've seen or have the concept of hub and spoke, but I'm going to talk about that in a little bit of detail. But as you can see here, team, we've got SORBA in the middle, namely the platform, part 2, as I mentioned there earlier. Okay. SORBA effectively is a data lake. Okay, if I was to use that terminology, it can take and ingest data from all of these different data sources, and I'm going to talk through them briefly here for 1 second and store it for you, okay, in a lake-based format, right? It has a limited amount of structure, i.e. it knows what tags and assets that the thing is associated to, but any sort of aggregation or relationships is not really built inside SORBA. Okay, yes, by all means, it can ingest the data. Yes, it understands assets, and that data is associated with that asset. Is there any sort of hard relationships between the assets? The answer would be no, hence the term lake. It's a data lake. It's really good at collecting data. In fact, it can do it in real time. Okay, as you can see here, it can collect data in real time from databases. Okay, some of these legacy systems may run on an Access 95 database. Been there, had one of those. Okay, so we can actually read data in from databases. We can read data in from APIs. We can read data in from historians. We can read data in from SCADA systems. As you saw, we can read data in from PLCs. We can, in fact, read data in from HMIs that may be connected to the PLCs. Okay, we can read data in, and the subject of this webinar is legacy systems. Typically, we do that via an SDC. So here's our Inosol RAND compressor being interfaced into SORBA. Okay, we can collect data from forms, i.e. human-entered forms, into SORBA. Okay. So as your maintainers run around or your operators are running around and making observations about things, that can be interfaced into SORBA as well. So it's not necessarily just limited to, let's call it machine-produced data. We can also ingest human-produced data. All right. IoT devices. Yes, we're really good at that one, and have a number of inbuilt tools to allow IoT devices to be data to be ingested into SORBA as well. In fact, we've got a few people doing that in Australia already. IoT devices allow you, for those that don't know, internet-based devices to, you can battery powered. They can be remotely anywhere you want, measuring whatever you want. It opens up a great possibility of interfacing data that's missing potentially in your plant into your corporate systems relatively cheaply. Okay, so we've got a whole heap of stuff around that, and of course, if you've got your SORBA SDCs out there, okay, it can be collecting data as well. You'll notice that this is basically a two-way street. So, can I pass data from an API into SORBA and then present that data onto a SCADA screen? Absolutely. Okay, so it is typically a two-way street between these systems. So, can I collect data from an IoT device and pass into a historian? Absolutely, yes. So, can I pass this data from a legacy system and say pass that to a PLC? Yes, you can. Can everyone see how that works? Okay, it's a two-way street inside SORBA, and the beauty of it is it happens in real time. Righto? It happens in real time. Okay. Again, I could be collecting information from a form, passing that through to a corporate database. All right. Now, I'm going to clean up my scribbles here, team, because I've got a few scribbles on the screen here. Now, the difference between a lake and a warehouse in layman's terms, okay, I'm not a data scientist, I'm a reliability engineer, but I've worked with warehouses before, okay, and one of the great things is that we can interface, as mentioned, to, say, Microsoft's SQL Server, i.e. Microsoft SQL Server can read us, or we can push that data to a Microsoft SQL Server, okay? You can put a thing on top of that right now. It's a plugin called SQL Server Analysis Services. It allows you to build the relationships to make it really, really easy to analyze the data that is collected from any of the data sources that are writing SORBA. Okay, you can use that in Excel or Power BI. So, cut a long story short. In fact, you can hook Power BI and Excel directly into SORBA if you would like. Okay, but people tend to use these warehouses to make it structured so that people can use it typically for business analytics, so non-real-time stuff. If you're after real-time stuff, absolutely hook Power BI and Excel directly into SORBA. Okay, but beginning with the end in mind there, team, we can take, let's call it run hours from our compressor, pass that through by this path and include it on your corporate reporting. Your compressors happen to be the most expensive energy source typically in your plant, okay? To make compressed air is rather expensive. That's what I'm trying to say. So if you wanted to manage those costs and have that cost appear on your management reports weekly, monthly, yearly, okay, we know the runtime. We could use the energy provider's API and pass it through here to calculate the exact costs, what your compressors are costing you. Okay, We can combine all that data and put that into your business analytics. We can collect this data, as it says down here, in real time. Okay, so if you're on an energy contract or a wholesale energy contract where the price goes up and down, we can collect that via the energy provider's API or the NEM API. Okay, and the pièce de résistance of all of this is because we've got all of the data coming into one spot. We can then apply AI, for example. If I pull in the data from, I'm going to clean up my mess here because this is a really important one. So I can pull in all of my operational data from my PLCs into SORBA. So I know what my plant demand is for compressed air. Remember, it's a two-way street between SORBA and the compressor. So we could use the AI to turn the compressor on and off so that we do not use excess energy, yet still maintaining the demands from the plant. Can everyone see how that works? Can everyone see how that works? Can you give me the thumbs up on that? Because once it gets into the SORBA, the AI functionality now becomes available to us. Because this is a two-way street, we could potentially control when your compressor or compressors, okay, and the variable speed drive, ramp the variable speed drive up and down to meet the demand without using excess energy. Okay, awesome team. So I'm going to leave the technical stuff here now and talk about some what we call misconceptions. All right, AI requires a full system overhaul. No. Okay. With SORBA, you just install the SORBA software, and then we can start integrating into whatever system that you so choose. So we're not changing existing systems. We can leave the legacy systems there. We just simply integrate them in. Okay. All right. Do not require a full system overhaul. Okay. AI is only suitable for large enterprises. You might have seen a little price tag hanging off my little SORBA for $20 a month. Okay. That's how much these little guys cost. I'll put a word of warning there, but we're about to have a price increase. Okay. So you can purchase only what you need inside SORBA. So if you are a small organization, okay, or have a small budget, we can basically tailor the solution to your needs. All right. AI won't work with legacy data. Hopefully I've dispelled that through this webinar that we love a challenge. We love a challenge. As you can see there, we've been thrown a number of challenges around the world. Okay. If it produces ones and zeros or produces data, okay, we can connect to it. If it doesn't produce ones and zeros, if it produces voltages, we'll figure out the hardware that's needed to connect to it. Okay. We offer what we call an operating system, a standard way of getting data in and out of all of your industrial systems. Okay. And getting them all to communicate, and on top of that, making all that data available to AI. Right now. Awesome, awesome, awesome. Now, if you're thinking about doing this, here's our step-by-step guide to integrate. All right, so number one, what we want to do is assess the infrastructure, okay? So we need to understand what the capabilities and limitations are of your legacy systems so that we can tailor a solution, okay? As you saw, we tailored the solution for that locomotive based upon their requirements. So if you good people have thought of what you would like to achieve, okay, we will design a connection profile around that. Now, you've got an idea on the hub and spoke piece of how this all works and how we can actually integrate it all in. All right. Then number two, start small and scale gradually. Okay. You do not have to flip the big switch like a ERP upgrade with SORBA. We can just install the software, low cost, start integrating into one system, prove that we can do it, get the ROI, see their return on investment, and then start integrating in. It's scalable. Okay, SORBA is scalable. You start out small, build up. Right. Then we've got a number of experts, as you could probably imagine, on team. We've got a number of partners here in the Asia Pacific that help us with all of this. We do not profess to know it all. Okay, here internally, we are really, really good with the SORBA software, the integration to different things. We tend to use our system integrators for that. Okay, we would recommend a system integrator based upon your needs and get those people involved, okay, to help us out. But it's all about what you want to achieve, your business goals, and we get the expertise or have the expertise in-house to allow you to do that. Then 4, upskill your employees. Okay, as I mentioned, we have the SORBA University. Okay, it can take your people from 0 to hero. It can teach you how to implement the AI systems. In fact, inside SORBA, you can, once you've got the software, to do offline analysis, there is no limitations on that. I'll say that again. There is no limitations to the amount of offline analysis you can do inside the SORBA system, i.e., you can get data from some data source, import it in, run it through the machine, what we call the machine learning trainer, and test if you're going to get return on investment or learn how to get the return on investment inside SORBA before you actually pay for an integration. If you can get the data into a CSV or some sort of file like that, we can import it into SORBA. You can test before you buy. Everyone understand that? Okay, that's step-by-step guide. Start out small, work it up. The system is flexible enough to do that. Can you give me the thumbs up on that? Thanks, team. All right. Last one. Who's using SORBA? These people around the world. Okay. Just to flash up who's using it and who we're helping around the world. Where can it be applied? It can be applied, as you probably tell, basically everywhere in an industrial situation. Okay, that's what it's designed to do. So we can talk about, refrigerators, boilers, heaters, dehydrators, kilns, furnaces, filters, membranes, heat exchangers, fans, compressors, turbines, engines, transport systems, building management, and more. We like it, as I said, the system is very, very flexible, very scalable is the word I'm looking for. So we can start out small and see how it will provide that return on investment for you good people. All right. Again, if you want to know more, please book me in. Please book me in. And I'm going to open the floor to questions. And
I noticed that you had BHP there. Was that an application within Australia? And if so, what was it?
The Bear trucks.
Oh, that was the truck, right? Okay, good. And her second part to that, is this applied to one truck or multiple trucks at this stage?
It was applied by multiple trucks.
Right. Okay.
Cool. So David, just to answer your question, there is no limitation to the number of assets that I'm aware of that SORBA can ingest at one time.
Okay, cool. Thank you.
Okay. So the rough rule of thumb with a smart data collector is 1,000 tags every second. Okay. And then essentially what the smart data collector does is it then compresses that packet into what we call a payload and then synchronizes that payload with the platform. So what it's doing is basically collecting the data in real time and then pushing it to the platform. And just to give you an idea of numbers, over a very crappy Telstra connection in the middle of central Queensland, from the time that an event happened on the truck to when we saw it on the platform was 10 seconds.
Okay. On that note, Peter, is StarHub playing a part in the more remote assets that you've worked on?
Starlink.
Starlink, yeah, Starlink.
Yes, the answer to that is yes. We were that excited about Starlink there, David. We tested it ourselves.
Yeah. Okay.
Yeah. And it worked brilliantly. I've even talked to people via telephone over a Starlink connection where they're using Telstra's Wi-Fi calling. So this particular person was in the middle of North Queensland, tropical Queensland, in a remote area up there, and he was talking to me via Wi-Fi, via Telstra's Wi-Fi calling functionality on his phone, via Starlink.
Oh, okay.
Yeah. So Starlink is opening this up, and especially with the next year, there will be cell to satellite functionality inside Starlink as well. So we're expecting it in early next year to get really, really exciting, where some of these device manufacturers like SendQuip are already integrating the chipset into their devices to directly talk to Starlink without a Starlink modem.
Oh, okay. It's interesting.
It's getting really exciting there, David. It is. Yeah.
Thank you, Peter. 7.
No worries. Sorry, Jason, you had a question?
No, I'm all good. I'm all good, mate. That's no problem at all. Yeah, the Starlink gives you options, with connectivity to remote areas for sure, and I see benefit in it. Most certainly. Yeah,
and just a note on that, before Starlink existed, one of our clients in South America, they had a plant that was remote, and they installed an SDC. And what the SDC does is, if it can't synchronize to the platform, it will simply store the data. And what happened was that they had a satellite that flew over once a month. And so what happened was the SDC would see this connection to the satellite and just all of a sudden go and blurt all the data up as the thing flew over.
There's other platforms that don't offer that functionality and they crash. Yeah. And they got scripting and other bits and pieces to try and do workarounds for it, which is exceptional on the SORBA platform.
Yeah. So basically we essentially the two parts to SORBA, as I showed you there before, is essentially the same software. So the platform software actually runs on the edge, and the edge software actually runs on the platform, and it gets all a little bit confusing. But the benefit of that is that the smart data collector is actually self-contained. So if it loses connection for whatever reason, it will just happily sit there and collect the data in real time. Okay, and when it sees the connection, it will then, synchronize and blurt the data up. So with those mining trucks there, David, what we saw was because it was a really crappy Telstra connection, when the trucks went down in the pit, we would lose connection. So then on the platform, we would just simply see the data stop. It wouldn't refresh because it's not receiving any. And then the truck would go down into the pit, get loaded, drive back out. And as soon as the connection was established, basically the data would backfill. In front of your eyes. You could be sitting there watching a graph, like I was watching suspension struts and stuff like this. And then, you could see the truck, because I'm seeing the data refresh basically every 5 seconds. I could actually see the truck, and I could forecast when I was losing connection. Okay. I could see the data stop because I knew where the truck was from the GPS that I showed you. And we knew that it'd be in the hole for about 20 minutes and then it'll pop back out. We're even getting to the point where we're forecasting when the trucks were going to come back. That's how, and then we can see the data starting to appear in SORBA. Thanks for attending there, team. and yeah, look forward to the next one. So I can't remember what we're doing the next one there, Ellie. Can you help me out? But we try to run a SORBA webinar every month here, team, where we introduce a new topic. Today was on legacy systems. As I mentioned, we've done beer brewing, how to optimize beer brewing. We've done machine learning for fault finders, so helping people fault find. All of this stuff is on the SORBA University. Yeah, if you want to ask me any questions, that's where you find me.